Imagine waking up in the morning, yawning, stretching, and realizing it's your birthday again. Except on Venus it literally is, because on this fiery, hellish neighbor of Earth, a single day is longer than an entire year. That's right, a full rotation on Venus takes 243 Earth days, but it orbits the Sun in just 225 days. Mind-blowing, right? But that's only the tip of the iceberg. Why does Venus spin so slowly? Could this bizarre rotation have a dark past? And how does it affect the planet's extreme conditions? Stick around because Venus's story is way stranger than you think. Let's talk about Venus. It's named after the Roman goddess of love and beauty, but don't let the romantic name fool you. Venus is anything but gentle. It's a planet of extremes: blistering heat, crushing atmospheric pressure, and clouds made of sulfuric acid. Yet, its most peculiar feature isn't the scorching temperatures or the toxic air. It's time itself. On Venus, time moves in a way that makes no sense by Earth standards. Imagine celebrating New Year's Day and then waiting over 8 months for the sun to rise, only to find out it's still the same day. What's even stranger? Venus rotates backward. If you stood on its surface and watched the sky, the sun would rise in the west and set in the east. But don't get too comfortable. It takes 116 Earth days for that sunset to happen. So how did Venus end up with such a bizarre rhythm? Was it always like this? Or did something catastrophic happen to slow it down? Let's unravel the mysteries of Venus's strange spin and what it reveals about our own planet's future. To understand Venus's slow rotation, we first need to figure out why it spins backward and why it spins so slowly in the first place. Planets in our solar system usually follow certain patterns. They rotate relatively fast, with their spin tied to the angular momentum they gained during formation. Venus breaks all those rules. Astronomers have puzzled over this for decades. Some theories suggest Venus might have been hit by a colossal object billions of years ago, flipping its axis and slowing its rotation to a crawl. Others think it could be the result of gravitational forces acting over millions of years, perhaps from the Sun or even other planets. But there's a bigger question. How does this affect Venus's environment? Its sluggish rotation has a massive impact on its weather, its geology, and even its potential to support life. Scientists are still piecing together the answers, and the story is far from over. Most planets, including Earth, rotate counterclockwise when viewed from above the North Pole. Venus, however, spins clockwise. This retrograde rotation is rare and unusual. One popular theory is that a massive collision in Venus's early history caused it to flip over. Imagine an asteroid or protoplanet smashing into Venus with enough force to completely alter its spin. An event so violent, it left scars that shaped the planet we see today. Another theory is that Venus's thick, dense atmosphere plays a role. Venus's air is about 90 times denser than Earth's, and its winds can reach speeds of up to 200 miles per hour. Over billions of years, this atmosphere could have acted like a brake, gradually slowing Venus's rotation to what we see now. Venus's slow rotation has some pretty dramatic consequences. For one, it creates extreme day-night cycles. Imagine standing on Venus during its day. You'd experience scorching heat as temperatures soar to over 900 degrees, hot enough to melt lead. That's because the sun's rays have an unbroken 243 Earth days to bake the surface. By the time the night comes around, the planet has barely cooled off, thanks to its thick atmosphere trapping heat. This slow rotation also means Venus has almost no magnetic field. Unlike Earth, which has a fast rotation that powers its protective magnetic field, Venus is nearly defenseless against the sun's solar winds. This has stripped away much of its water and left the planet bone dry. Venus is often called Earth's twin because it's similar in size and composition. But the differences couldn't be more striking. Understanding Venus's rotation and its consequences might help us predict the future of Earth. Could our planet's rotation slow down one day? What would happen to our climate and life if it did? Venus offers a glimpse into a possible, though extreme, scenario. After decades of study, scientists are starting to connect the dots. Venus's slow spin might be a result of tidal interactions with the sun, combined with its dense atmosphere acting like a drag. But here's the kicker: Venus's rotation is still changing. Recent measurements show it slowing down even more, by fractions of a second every year. It's a living, evolving system that's teaching us about the delicate balance of forces shaping planets. And here's the part that might blow your mind. Despite its hellish conditions, Venus's slow rotation creates a region in its upper atmosphere where temperatures are surprisingly mild. Some researchers even speculate this could be a potential habitat for microbial life. Could Venus, the planet of extremes, hold secrets about life beyond Earth? Venus is more than just a planet with an unusual day. Its slow spin, backward rotation, and extreme conditions make it one of the most intriguing places in our solar system. By studying Venus, we're not just learning about a distant world, we're uncovering clues about Earth's past, present, and future. Venus challenges everything we think we know about planetary science, and it's a reminder that the universe is full of surprises.